I will just share my screen.
Okay, sure, sir.
Huh? अच्छा, स्क्रीन दिख रही है अभी?
Yes, sir. Perfect.
ठीक है,
Yeah, it is moving, sir.
2 मिनट। एक वीडियो है, वो वीडियो का आवाज आ रहा है क्या? देखो।
नहीं सर, इसका तो नहीं आ रहा। Is not.
ठीक है, तो वो शायद इसके शेयरिंग में कोई इशू है। 2 मिनट। अभी भी आवाज नहीं आ रही है?
आ रही है सर।
आवाज आ रही है ना? ना,
हाँ
मेरी नहीं,
सर,
वीडियो की।
वीडियो की नहीं आ रही सर।
नहीं, वीडियो की नहीं आ रही सर।
क्या करे? ठीक है, मैंने शायद हर वीडियो में एक यूट्यूब लिंक दी थी। मैं यूट्यूब लिंक भेज दूंगा कि गूगल इसमें ऑप्शन नहीं दिखा रहा है कि ऑडियो को भी शेयर करे।
So, good evening, all of you. We have our esteemed speaker, Professor Sachin Mandavgane from VNIT Nagpur. Shall we start, sir?
Yeah, we should start.
Okay. Thank you very much, sir, for accepting our invitation in a short while, and you give us very time from your busiest schedule. So let me take the opportunity to introduce Professor Sachin from VNIT Nagpur. He is currently working as assistant, as a professor and head of the department in Department of Chemical Engineering at VNIT Nagpur. His interests include solid waste utilization, nanocatalyst absorption, green chemistry, ancient science, green building material, engineering education and social media, alternate construction material, and all. Professor Sachin graduated from Nagpur, Lakshmi Narayan Institute of Technology, Nagpur, and earned his BTech, MTech, and PhD, all three degree from Lakshmi Narayan Institute of Technology, Nagpur. Sir supervised 9 PhD students and currently leading 4 PhD scholar and more than 15 students supervised as a postgraduate. More than 100 publication against his name, and he has more than around uh, a good number of citations. Sir has played the role as a chairman, Board of Studies of Chemical Engineering at VNIT Nagpur, member of various committees and convener of the various committee at the VNIT Nagpur, and organized more than 20 workshops as a coordinator and convener during his tenure last more than 20 years. He has more than 20 sponsored R&D projects, some of the completed and some are currently running. He is leading as a principal investigator of these projects. So with these introduction, I would like to invite and hand over to Professor Sachin. Sir, over to you, sir.
Thank you. Thank you, Krishna Kumarji, and good evening to all the participants present here. I will start sharing my screen. Uh, so, taking into consideration the theme of this ATAL FDP, supply chain management in agribusiness, I'm going to share with you one very interesting business model. And this business model we developed with Niti Aayog in somewhere in started in 2017 when the Prime Minister of India made announcement, a very ambitious announcement of doubling the farmers' income. So Niti Aayog constituted one task force, and in that task force, the very objective was innovative models for doubling farmers' income and addressing their issues. So I supported the committee members in this task force. The objective was by increasing the productivity of the land, the income is not going to increase because anyway from 1 acre of land, if I am having say 5 quintals or 10 quintals of a material, if I double it, it doesn't mean that directly my income will double. The agricultural market is highly complex market. So the thought was, can we make use of the waste which is available in agricultural field for creating some valuable products, right? And what are those valuable products? Those valuable products should be such that those products meet the basic needs of the society. So I'm going to tell you what are all the basic needs, and then I'm going to tell you that what are all the waste that that has been catered and that can be catered. So I will be talking more of the research that we have done, and not the lab research, the work that we have done actual in the field, in the industry, right? And couple of pilot plants that has come up. And in the entire process, where the supply chain of agricultural waste is an important issue, and second is technology. So we have developed technology, and we are confident enough that technology, we can have a versatile technology such that even if the agricultural waste, the nature of the agricultural waste is changed, we could get products. Now let us first understand the the nature of the products. What types of product are we looking for, right? So you might be knowing or might not be knowing. There was a Delhi election in 2002-2003. Sheila Dikshit was campaigning, and that time uh, uh, it was said that समाज के लिए क्या चाहिए, रोटी कपड़ा और मकान, right? So these are the things that all of us know, that roti kapda makan are the basic needs. But then that was the election where, I'm telling 20 years before, तब कहा गया रोटी कपड़ा मकान and mobile, right? Now you see, your and my life is just incomplete without mobile. So the basic needs of mankind, which are roti kapda makan mobile, if I try to put it into very elementary things, what I require is energy. I require energy in the form of electricity, or in the form of heat, or I require energy for transportation as a transportation fuel. Then I require organic chemicals. Now you will say that why organic chemicals? The entire farming is around organic chemicals. Your and my life is just incomplete without organic chemicals. We eat lot many fermented foods, right? Those who are fond of pizza and burger, that is all fermented food, right? And that is just not possible without organic chemicals. So organic chemicals, one, agriculture. I'm giving you just some examples which are popular examples, but that those are not the example incomplete. The paints that we are having, right? We just cannot have anything excluding C, H, and N. So the combination of this C, H, and some or the other form, they give us organic chemicals, right? And third is polymers. The laptop that you are using right now, it has polymers. The mobile, if you are logging through mobile, has polymers, right? The television that you watch, the two-wheeler that you drive, the helmet, the your watch, right? You just look around in your room and you'll find that there is a lot of polymers around. Do not get confused with plastic and polymer, right? So only single-use plastic is hazard. That's a curse. Otherwise, your and my life is incomplete, right? Now, if these are the needs of society: energy, organic chemicals, polymer. Who are meeting these needs? Right now, the single source of all these needs are crude oil, right? And if you ever read the history of Middle East, which has the largest resources, the reservoir of crude oil, they have the jackpot of crude oil wells in their 1950s, 1960s. Before that, I think I strongly suggest all of you to read the history of Gulf, the Middle East, the UAE, and the emergence of crude oil business and the emergence of economy based on crude oil. The question is that if the crude oil has been in existence in 1950, 1960, so what was the source before that? So we have witnessed the First World War before that. We have witnessed the Second World War before that. So then there that time, what was the source? Right? That's a very important question. Now the source of carbon and hydrogen to make energy, to make organic chemical, to make polymers is crude oil. Then when there was no crude oil, what was the source? I'm not giving the answer. I'm just moving forward. So right now what is happening is we have a crude oil and we use that crude oil as a source of carbon and hydrogen, and using that crude oil as a source of carbon and hydrogen, arrays of products are made, different types of products, right from gasoline is your petrol, then diesel, kerosene, tar, chemical soon, right? And what are all these petroleum refineries? When you are traveling along the highways, you'll find many petrol pumps, right? And you'll see BPCL, Bharat Petroleum Corporation Limited. Then you'll find IOCL Petrol Pump, Indian Oil Corporation Limited. You'll find HPCL, Hindustan Petroleum Corporation Limited, right? You'll get LPG cylinder at home. Bharat ka LPG hai. So these are all giant PSUs, and so is Reliance. So Reliance also has its own refinery in Jamnagar. So what they do, they use crude oil. Now, Middle East, the Gulf is the source of crude oil, no doubt about it. But even in India, in different parts, we are getting the crude oil reservoirs, right? Here, what is done is I am using one raw material, crude oil, crude oil. I make arrays of products, right? Like that when there was no crude oil, तब क्या था? तब भी तो लोगों को एनर्जी मिलती थी, तब भी तो लोग खाना खाते थे, भले तब शायद पॉलीमर नहीं था, पॉलीमर वाज इन डिफरेंट फॉर्म्स, लेकिन नायलॉन 6 18th century. So 19th century शुरुआत हुआ. Then what was the source? Right? The source was coal. It was all coal. The revolution that has taken place, the industrial revolution, the French Revolution, the European industrial revolution took place because of the steam engine. The steam engine was the biggest invention in last 400 years, last 300 years. And that has led to machines, that has replaced animal-based power, human-based power, and come up with automotives, the train, machineries, right? And since these inventions have come up, the productivity has increased and the mass production has started taking place. Then places like Europe, they find that they have the technology, they have the know-how of mass production, but they do not have the raw material. So what to do? So they use India as a place from where the raw material, merely the raw material is taken from India. It was processed there, and then once again it is sold in India, right? So it is all coal. So it was a coal-based economy. If you read the way the energy and all the source of carbon and hydrogen was coal. And what was before coal? It was again plant-based herbs. If you read Ayurveda, There are so many formulations, the medicinal formulation, many things are there. They're all herb based, right? And if you see the way the crude oil is made, the crude oil, because of high pressure, they are buried under the soil, high pressure, and for a real long time, it is highly condensed energy, right? Highest condensed energy is your crude oil. Before that, it was coal, and before that, it was wood, herb, wood kind of material, right? But the objective was all these three, whatever I'm talking, they're the source of carbon and hydrogen. Now, people are now once again looking at the plant-based material as a next source of carbon and hydrogen, right? And if we have carbon and hydrogen once again from plant, then they should make the same product what we are now getting from the crude oil, right? Therefore, I want chemicals from plant, biochemicals. I want fuel, biofuel, right? I want polymers, biopolymers, right? Now the question is that, can I get all these societal needs which are required for the existence of yours and mine, not from crude oil, but from bio-based materials, right? And that's what the biorefinery all about. So in case of a biorefinery, just like in case of a petroleum refinery, I make use of a crude oil and make arrays of products sequentially one after another, right? Similarly, here I will be using biomass. Again, the biomass is divided into different types of biomasses. You'll find grass is there, agricultural residue is there, forest waste is there, or if you take oil containing seeds, or if you take starchy material, if you read about the way the Latin America, the Brazil, and a part of US is working, they are harvesting starch for the fuel, right? They're harvesting starch for polymers also, right? Therefore, I'm now doing farming to grow energy, right? Your cabinet minister, who is member of parliament from Nagpur, Nitin Gadkari, his very pet dialogue is that your Annadata should become Urja Data, right? He is working very hard for that. That the Annadata should not remain only for harvesting food, but even harvesting energy, right? And there are multiple types of biomass materials, right? From different types of grasses, different starchy materials, right? Then oil containing seeds and agricultural residue as a source for different for making different products. Yeah, I can have energy crops, grass, all these bamboo, sweet sorghum. These are different types of grass, right? Then I can have agricultural residues, the stack, the place from where I belong to, Nagpur. This is known for cotton. So cotton gets flowers. One plant gets 3 to 4 times flower. Once you pluck those flowers, the rest remaining is your cotton stack. Now you must be reading or following the national news, and in the national news you'll find that the air quality index of Delhi is very pathetic, right? Because what's the reason? The reason is again agricultural residue, the paddy straw. The paddy straw is fired in the field itself, and that gives a lot of smoke. Then I can have forestry waste, I can have industrial waste, right? Fine, I will move forward. If the audience is from chemistry background, if they can appreciate, I can classify the biomass based on the content. Oil based means triglyceride, right? You must have heard about Jatropha. Then we have this. Then you must have sometime you must have ate the dalda ghee. Dalda ghee is animal fat, right? So the triglyceride, then sugar and starchy. We have this sugar cane, ganna, then sugar beet, sorghum, the starchy material like corn, maize. Huge farming of maize is in US just because they want starch. Then lignocellulosic feedstock, the straw and the grasses that I was referring to. Fine. I'm just building up the background so that I can take you through actual cases. So before you appreciate a case study, you should know the background, right? Now, what the petroleum refinery does? Petroleum refinery makes three products. One, it makes syngas. What is syngas? Syngas is a combination of hydrogen, carbon dioxide, methane. Very small molecule, gaseous state, as a fuel. Then second is olefins. Olefins are unsaturated hydrocarbons. They have double bond. Ethylene, 2 double bond. CC. Propylene, 3 carbon, 1 double bond. Butadiene, 4 carbon. Then aromatics. So these are all green. Benzene, toluene, xylene. So this is what basically a petroleum refinery makes. And once these are made, using these as a platform chemical, our three basic needs: energy, organic chemical, polymers. So for example, if I take ethylene or if I take propylene, right? So one ethylene molecule attached to another, to another, to another. So it becomes polyethylene. So polyethylene bags. So polythene. So we have condensed and we are calling as polythene bags, right? So ethene, all these things are something which the petroleum refinery produce. If I am not using petroleum refinery and if I am using biomass materials, the starchy material or say energy materials, right? So from any biomass, these are the platform chemicals: the glycerol, sorbitol, levulinic acid. I will not go into detail of this. Okay. So what we have done? Now this is the actual work that we have done. We did. We work on paddy straw. We work on sugarcane trash. These are two technologies which are commercialized. I'm going to show you something about this, right? Then we work on biomass ash. Then we work on different fruits and vegetables, right? And we try to make the products which are required for the society. Then we are working on agricultural waste for functional food for animals, right? And we are working on neem biopesticide. This is also commercialized, right? Wherever possible, I'm going to show you a couple of videos to you, right? So I will move forward. This is potato biorefinery. Now, you must be knowing that 2 years or 3 years before, there was a lot of agitation in the NCR, then your West UP, that farmers are not getting price for potatoes. So then government has come up with mission TOP. So TOP stand for tomato, onion, potato. So we picked up these potatoes, right? And in this case, this is a pre-commercial stage. I'm going to show you the pilot plant of the same. Now, we work for an industry that is Merino Industries, which is at Hapur, near Ghaziabad. They are in the business of potato ready mix. So what they do is they have contract farming as well. The potatoes, as they come to the plant, it has to be peeled first. So the peeling is done either mechanical peeling, जैसे घर में हम छीलते हैं, that's the mechanical peeling, or it's a steam peeling. In case of a steam peeling, the potatoes are exposed to high pressure steam momentarily, right? And the only outer surface get loosened, and then that peel is passed through brush, and the peel and it is peeled off, right? And while whether it is a steam-based peeling or whether it is a mechanical peeling, along with the peel, some starchy part get attached to that. You must have seen that the peel has some safed color ka material which is attached to that, right? And there in this industry, they are producing close to 5 to 7 tons per day It's a huge quantity, right? We have come up with a sequential products from this waste, right? And the products which we are making are following nutraceutical, then the dietary fibers, we are making prebiotics, biogas, and compost, right? And I will share this link with you in the chat box because you may not get audio for that. So just a moment. I'll share the chat box. Okay. Right. So I will just run through this. Oops. I'm sorry.
Sir, it's saying that video is unavailable.
हैं वीडियो अनअवेलेबल बोल रहे हैं
Yes, sir.
2 मिनट मैं इसने गलत तो वीडियो नहीं शेयर किया 2 मिनट रुको आप YouTube में जाइए और ढूंढिए पोटैटो बायो रिफाइनरी पोटैटो बायो रिफाइनरी मैं आपको दे रहा हूँ आ गया हाँ try this
Yes, sir, it's working.
ठीक है
Yes.
है वर्किंग तो अभी मैं यहाँ पे चला रहा हूँ ठीक है सी दिस इज द प्लांट जो हापुड़ में आया हुआ है this is the first time where we are separating the white part from the peel the white part goes for anaerobic digestion ये आ गया this is going for biogas these are the peels which we are drying from this we will extract antioxidants and we will make nutraceuticals so Vegit is the brand of these people merino people so before actual pilot plant we did a lot of lab level work then some lab plus in buckets so we are working on food supplement bioenergy from different products different food waste I'm going to show you about our orange we work apple pomegranate tomato onion also right fine so the project was funded by Department of Science and Technology and merino is the industrial partner who put a lot of money in establishing this entire plant. We move next. This is about oranges. Again, Nagpur is known for oranges. If I consider only Nagpur, then in Nagpur division, 1.85 lakh tons, 1.85 lakh tons of oranges are prepared are produced, right? But because of poor transportation, बारिश आती है, untimely, weather खराब है, अलग-अलग reasons है, oranges नीचे गिर जाते हैं. Oranges सब नीचे गिर जाते हैं. They are waste. They are not sellable. So farmers are not getting money for this, right? So we have come up with the two models. One model is the model that I'm going to show you now. This is about centralized plant जहाँ पे raw material will come at one place and we will make it. And second, which I am not able to show you because that entire process is a file for patenting. Ministry herself has filed the patent on that work. So I will show you this video. जहाँ पे this is once again at Hapur. What we have done, we have collected the orange peels from the roadside vendors. You have roadside vendors, and we collected peels of oranges as well as sweet lime, that is Mosambhi, and we made products out of it. So our raw material is a waste, and each these peels have oil content in that. So our products are following. We extracted orange oil, or we call it as a citrus oil. उसके बाद में जो बचा उसमें से we extracted pectin. Now what is pectin? Pectin is used as a gelling agent. जो आप ब्रेड के ऊपर जाम लगाते हैं, that jam का जो नेचर है, जेलिंग नेचर, that is because of pectin. And then they have extracted cellulose fibers, right? You watch this video. ये वीडियो का भी मैं आपको 2 मिनट, जस्ट 2 मिनट, ये वीडियो का लिंक मैं आपको देता हूँ। और इसमें ऑफ कोर्स आपको सुनने में बैकग्राउंड म्यूजिक ही मिलेगा, बाकी तो बाकी इसमें दिया हुआ है। Watch this, and now I'll come to this.
So it's also showing that video is unavailable.
अभी यहाँ देख लो, चलो वो म्यूजिक है आपको, अच्छा सुंदर गाने
अच्छा
सुनने को
अच्छा
मिलेंगे
अच्छा
वाकई।
नहीं ठीक।
ये कलेक्शन किया रोड साइड वेंडर से, साफ सुथरा किया, धोया, तो पल्वराइज किया, बारीक पाउडर बनाई, दिस इज स्टीम डिस्टिलेशन यूनिट। एंड वी गॉट ऑयल। ये साइट्रस ऑयल, ऊपर वाली जो लेयर है, the leftover, we put it into the reactor to get microcrystalline cellulose and pectin. This is pectin. So no waste, everything has been converted into product. So we collected this peel waste from these vendors, right? So here the big challenge is the raw material. If I'm working in agricultural waste, the challenge is the raw material transportation and supply chain. इसमें बाद में आता हूँ, इसके पहले मैं आपको ये चीज बताता हूँ। This I will talk around. So if anybody has anything to ask, you please ask me. Else I will talk to you about a very interesting topic, that is about this product Bajrang Band. लेकिन I can take a pause, 2-4 मिनट रुक सकते हैं, किसी कुछ पूछना है? Fine. You can post it in the chat box as well. किया गया ये में फाइल कर रहे हैं तो लोगों को बताया कि आप डोंट कीप इट इन पब्लिक डोमेन, ठीक है सर। तो now I'm having a presentation on 9th and 10th in Delhi about this product once again. This is all about paddy straw. So we have come out with a culture which can digest paddy straw, sugarcane trash in as less as 3 weeks time. And this is a product which we developed as a part of Merino Innovation Center. And one VNIT student has a startup around this. It's a create, right? And you watch this video. Pictures है, but you watch this video. और यार इसका ऑडियो काम का है शट। कॉपी, मुझे लगता है ये काम करता है, ये इसमें सुनना जरूरी है। देखिए तो ये वीडियो काम कर रहा है या ये भी प्राइवेट है?
सर काम कर रहा है।
तो सुनो आप लोग, मैं तब तक 2 मिनट रुकता हूँ। आवाज आ रहा है ना उसमें?
यस सर आ रही है।
And the Vishweshwaraya National Institute.
हाँ कोई चला दे, गौरव चला दो, आपका अनम्यूट निकाल दो।
व्हाट सर?
कोई चला है नहीं, कम से कम यहाँ ऑडियो आते रहेगा।
अच्छा ओनली ऑडियो सर?
हाँ जो भी है, आप शेयर करना, शेयर करो वीडियो, मैं स्टॉप करता हूँ।
ओके सर।
क्योंकि मेरे यहाँ से वीडियो ऑडियो शेयर नहीं हो रहा है, मैं स्टॉप करता हूँ, आप शेयर कर लो। केवल ये वीडियो।
ओके सर, ओके सर। 3584353854 how to paddy.
हाँ करेक्ट, फुल स्क्रीन कर दो।
In a laudable industry academic collaborative venture, Merino, along with the Energy and Resource Institute and the Vishweshwaraya National Institute of Technology, Nagpur, has adopted a cost-effective method to convert paddy and other agro-waste into a soil-enriching compost. This is an environmentally friendly alternative to stubble burning. Large quantities of paddy straw is collected from in and around Hapur and stored in sheds. It is then reduced in size by a pulverizer. After this, the shredded and crushed paddy straws are fed into a ribbon tray, where the patented bioculture is sprayed into them and it undergoes dry digestion.
Merino Innovation Center has come up with a unique culture, a biodigester, which digests paddy straw in as less as 3 weeks time, which otherwise takes 3 months to 6 months. And the product is patented. Not only so, the product has commercialized with a title as Bajrang Baan. So Bajrang Baan is a very unique decomposer, microbiological consortium, which is used for rapid composting of paddy straw, which we can do as a centralized facility, like what we are doing here in Merino. On a pilot level, 1 ton of paddy straw on a daily basis is being composted, is being digested, which we are now scaling up to 15 tons per day.
The primary aim of the patented bioculture is to tackle this huge problem of bio-waste and its fruitful dispensation. It is aptly named as the Bajrang Baan. The mixture is then collected and stored in plastic bags, which themselves act as an anaerobic digester. With the help of the microbes in the Bajrang barn, these shredded paddy straws get decomposed in 21 days and then is an organic manure for agro use. The process is simple, but the result is a remarkable alternative to a major environmental problem. Professor Sachin Mandavgane tells us of the meaningful and valuable collaboration that Visvesvaraya National Institute of Technology has with Merino Industries.
VNIT, Visvesvaraya National Institute of Technology, and Merino Industries, we enter into an MOU, and as a part of that, VNIT is having Merino Innovation Center. In that innovation center, we are taking up different projects under the sustainability related topics. The lab work, typically we call it as development of proof of concept. The proof of concept is developed in VNIT laboratories. MTech students, PhD students, even the undergraduate student work on these topics. Once the proof of concept is established, then for scaled up study, for a pilot plant study, we come to Merino. So the understanding is following. The basic laboratory work, basic experimental work, which I would be doing maybe in 100 grams or 500 grams of quantity, is done in VNIT. We develop the proof of concept, we develop material balance, energy balance, general understanding. Once that is done, when I have to go for maybe 10 kg, maybe 15 kg, 50 kg of material, we call it as a lab plus experiments. So those lab plus experiments are carried at Merino campus, where the students who work in the laboratory, they themselves come here. So now they get the exposure of industry. And we carry out the lab plus experiments. Once the lab plus experiments are successful, we go for a pilot plant, where the couple of students are having their PhD topic around this. So they are doing their PhD as well as they are solving a real life problem. So instead of solving an unsolved problem, the students are working on the problem for which the solution is needed.
ठीक है, हो गया ये, right? So this is what about this paddy straw, right? अब आ जाओ बाहर. I will now start sharing. वीडियो आप शेयर कर देना, और भी कुछ है सामने वीडियोस.
Okay, sir.
तो दिस इज दिस बजरंग बांड. उसके बाद में ये पूरा प्लांट है जहाँ पे फिलहाल 2 टन पर डे प्रोसेस किया जाता है. आप कोई आजू बाजू में होंगे रहने वाले, यू कैन गो एंड विजिट दिस प्लेस. ओके, so the next topic is another interesting thing. Agricultural residue are converted, they are compressed, they are passed through extruder, and once they pass through extruder, they form a briquette. So biomass briquette is a big business, and biomass briquettes are used as a fuel. So they replace coal, they replace oil and material like paddy, rice husk और sawdust. ये जो है इनको श्रेड करके it is passed through extruder, and extruder से पास करके they make these briquettes. So briquettes are of 2 dimensions generally. One dimension is 6 inch का and 1.5 feet लंबा रहता है, और दूसरा छोटे रहता है. जैसे आप भगवान के सामने धूप वगैरह लगाते हैं, उस टाइप का समझ लो 1-2 इंच, 1/2 इंच डायमीटर और 3-4 इंच का लेंथ. So cylindrical kind of thing. So these are used as fuel, right? And generally they cost 4 rupees, 6 rupees, and farmer also gets some additional money out of it. But the issue is, this is good. This is one part of the story. The other part of the story from the industry point of view is that when these materials, the biomass briquettes, are fired in the boiler furnaces, they form ash, and this is called as a biomass ash. This ash is unlike your coal ash, because thermal power plant also make coal fly ash, but these are not the coal fly ash. This is because this is the ash which is produced from the plant, agricultural waste, agricultural residue. So if you understand the plant growth, during the growth phase, in presence of sunlight, plant undergoes the photosynthesis and the organic part is formed. Now, when this is fired, burned in the furnace, we get the ash. The ash contains the inorganic part. Now, from where the plant got this inorganic part? The inorganic part is absorbed by the plant from the soil, right? The organic part is synthesized in presence of sunlight and carbon dioxide. But the inorganic part is something the plant has taken from the soil. So it's very logical that I should take that ash back to the soil and complete the circularity. But the challenge is this ash has very high pH, high electric conductivity. It is a very rich source of potash and phosphorus. For your kind information, India imports potash. And government wants technologies to substitute the imported potash. So this is a very nice option for that. But the challenge is I cannot use that ash directly, right? So once again, we have come up with another culture. We call it as Angatban, which makes the potash and phosphorus water soluble. It regulates the pH and EC. And what we found is if we use 1 ton of biomass ash per acre of land, we can reduce 25% of chemical fertilizer requirement, right? We are doing these trials with IARI Delhi, PDKV, couple of industries are also involved. They are also trying this thing, right? So that objective is use of this biomass ash in agriculture as a source of potash, and you replace the fresh application of potash, right? And this is this culture. This is the wrapper, and once again, this is this patent is filed. As far as Bajrang Band is concerned, the patent has been granted. Then next part is we are working on neem. Again, the areas which are forest dominant or somewhere in Tamil Nadu also, a lot of neem is harvested. नीम के ही पेड़ लगाए जाते हैं, 5,000 पेड़ लगाए हैं, 500 पेड़ लगाए, 1,000 पेड़ लगाए, right? Now I'm giving you different technologies, but in all these, the real challenge is the raw material availability and supply chain, right? My point is that, see, the orientation of my talk is some valuable products from agricultural waste, so that overall income of the farmers is increased. That too through sustainable agricultural practices. Here, neem is known as a pesticide for ages. But the challenge is different. The challenge is the key component in the neem is highly unstable. If it is exposed to sunlight, it gets degraded, right? So if I'm using neem as a biopesticide, I have to spray it very frequently. So VNIT has come up with a technology where we are keeping the key component in its natural form without extracting it. Now the innovation is making free-flowing powder of oil-containing seeds. If you take a groundnut, घर में आप यदि मूंगफली का दाना लेते हो और उसको पीसते हो, you will not get a free-flowing powder. It forms lump because it has oil, right? तो हमने यही कोशिश की कि oil होने के बाद भी वो free-flowing रहे, and that's the innovation. So this technology is now disseminated by BARC and Ministry of Panchayat Raj. 22-23 लोगों ने, हाँ यहाँ ये सब लोग हैं, आज तक 2-3 साल में ये टेक्नोलॉजी काफी लोगों ने खरीदी है, कमर्शियलाइज भी करी हुई है। वी डू सम इसके पहले मैं आपको एक दूसरा वीडियो दिखा देता हूँ, एक काफी इंटरेस्टिंग वीडियो है। लिंक भेजता हूँ, हम वो एक वीडियो देखते हैं और बाद में बाकी के टॉप पे आता हूँ मैं। मैं अभी फिर से एक लिंक देता हूँ और ये इसको शेयर करो, इसको चलाओ जरा। काफी इंटरेस्टिंग है, जरा देखना ये चलता है क्या और आवाज आता है कि नहीं, और शेयर द स्क्रीन। अबाउट ग्रास एंड नाउ इन DNIT वी आर डूइंग द सेम थिंग फ्रॉम इंडियन पर्सपेक्टिव। ये आयरलैंड का वीडियो है, जरा देखिए चल रहा है क्या। राइट, चलिए।
We always knew that grass was a very good product, but this is opening up our minds. Wow, is there more to it than we actually thought? Can we do more with it?
We would see a lot of similarities with this project and I suppose milk. There's a lot more to milk than just milk. We can make cream, cheese, whey protein ingredients. And with the grass, I suppose today it is just eaten by the cow, whereas with this project, you've gone from 1 to 4 products.
Here in Cork, this prototype machine is squeezing every last drop of goodness out of grass. Grass goes into the machine. This pressed cake silage comes out. And this protein-rich juice from which we can produce pig feed, prebiotics and bioenergy. In a traditional agriculture system, grass will simply be fed to cows, to beef cows, to dairy cows. We're trying to optimize the whole potential of grass. The cows are still getting the protein that they need, and we're extracting materials which they don't use very effectively and separating them to produce new products. We import huge amounts of biofuels, chemicals, protein, fertilizers, which if we use our raw materials much more effectively, we'll be able to meet all those market needs. From the juice fraction, we can get 3 different streams. We can get a protein product, which can be used to feed chickens or pigs. We can get a high-value stream of sugars, which are a prebiotic, which can be used in animal nutrition or in the cosmetic sector. And then the residues that are left contain a lot of monosaccharide sugars, a lot of nutrients, and we can use that potentially for biogas production or for the production of biofertilizers. I think small-scale biorefineries like this are something we're going to see on farms. They're being developed with automation built in so that farmers can take up these types of technologies, and they can allow farmers to improve resource efficiency, but also address key emissions challenges. Instead of farmers playing the role of just supplier where there's very little value add, we're turning farmers into producers of products, so a lot more value can stay on the farm by using the small-scale biorefinery approach.
ठीक है, ये हो गया। Very interesting. I like this thing. And we are doing from Indian perspective. Same thing from Indian perspective. इंडिया में जो ग्रास है, इस टाइप का नहीं है. So, but using this clue, we are trying to make it from Indian perspective. Then I will come to almost last couple of slides, almost done. So, yeah, तो ये कुछ चीजें हम लोग करते हैं. सस्टेनेबिलिटी एक स्टार्टअप है हमारा, सस्टेक सॉल्यूशंस, sustacksolutions.in करके आप ढूंढ सकते हो. We are catering to 30 around more than 30 industries for doing the life cycle assessment, impact analysis करना है. If they have multiple options of products, multiple option for routes, एक रास्ते से जाना, कौन से रास्ते से जाना, environmentally कौन सा रास्ता सही है. So that is something that we do for the industry. So Sustek does it. That is my PhD students' work. So I acknowledge these people who all the way help in doing all these things. Science and Technology, Department of Science and Technology, APR, CPA, Ministry of Food Processing है. अच्छा वो ओनियन का और पोमोग्रेनेट का दिखाना रह गया. वो स्केल अप होगा तब मैं आपसे फिर से बात करूंगा. तो वी आर वर्किंग ऑन ओनियन. नासिक में ओनियन है, पोमोग्रेनेट सोलापुर में है. तो वेस्ट ओनियन और वेस्ट पोमोग्रेनेट के ऊपर हम लोग काम करते हैं. एंड कमिंग अप विद यही एक बायो रिफाइनरी लेके आए. वेस्ट एग्रीकल्चरल जो है उससे अलग अलग प्रोडक्ट बना सकते हैं. सो ये हमारा कुछ थ्योरेटिकल काम है, मैं इसके ऊपर बात नहीं करूंगा. और एक आखिरी है, बहुत पहले किया हुआ है, मैंने सोचा कभी आपसे बता दूं कि यूज ऑफ न्यूज़पेपर वेस्ट जो हम रद्दी बेचते हैं. सो व्हेन वी सेल आउट 1 kg ऑफ न्यूज़पेपर, around 850 get recycled and 150 is the best forever. So we have made this bricks out of it. They are thermal insulating lightweight bricks, and this small prototype home 1 meter by 1 meter by 1 meter, which is the terrace of VIT Cleaning Department. It is since 2010, 12 साल हो गए. It is withstanding all weathering conditions और अभी भी सही तरीके से काम कर रहा है. It is still there. Thanks a lot. I'm done. If anybody has a doubt, question, I would be happy to answer that.
The audience kindly ask the questions. It was a very nice and wonderful lecture. Any questions? Gaurav? Yes.
Sir, that was a very informative session. सर मैं वैसे इस फील्ड से उतना नहीं हूँ, बट मेरे लिए बहुत ज्यादा इंफॉर्मेटिव रहा है. सर आपने बताया था कि जो गडकरी साहब हैं वो बोलते हैं अन्नदाता जो है वो ऊर्जा दाता उसको होना चाहिए. तो
जी जी.
तो सर मैं थोड़ा सा कंफ्यूज था इसमें. पार्डन मी इफ आई एम रॉन्ग. वो क्या इस रेफरेंस में बोलते हैं? मैं मुझे लगता है कि शायद वो ऊर्जा से उनका मतलब सोलर प्लांट से है.
ना ना ना, उनका कहना ऐसा है कि इथेनॉल के ऊपर उनका ज्यादा जोर है, सोलर से नहीं है. उनका ये कहना है कि हम इथेनॉल बनाए, बायोगैस बनाए. ये जो एग्रीकल्चरल वेस्ट है, ये एग्रीकल्चरल वेस्ट से हम बायो सीएनजी बनाए, बायो इथेनॉल बनाए, और ये बायो सीएनजी बायो इथेनॉल जो है दैट इज फ्यूल.
ओके सर, थैंक यू सर.
विश्वास करता हूँ लोगों ने सुना होगा, केवल लॉग इन करके छोड़ा नहीं होगा.
Any other questions? Ishwar, Nitesh, Jagdeep? Nitesh?
ठीक है, कभी बाद में भी सवाल आता है, आप पूछ सकते हैं.
Yeah. Nitesh, your voice is not coming. Hello? I think, sir, you answered all the questions. So, thank you very much, sir.
धन्यवाद धन्यवाद धन्यवाद.
It is a nice introduction, and we love to invite you once again in future as well.
जब भी आऊंगा मैं आऊंगा. ऑनलाइन की वजह उत्तराखंड आना है.
Yes, sir. It would be great if you are coming offline next week. We love to
नेक्स्ट वीक
invite
तो
you.
नहीं पॉसिबल यार. नेक्स्ट वीक में दिल्ली में हूँ वैसे 9 और 10.
Okay, okay.
तभी आऊंगा, पक्का आऊंगा.
Okay, certainly, sir. Thank you, sir. Thank you very much.
धन्यवाद धन्यवाद. थैंक यू.
So So all the participants are requested to take the test. I'm going to share the test in Google Sheet shortly. After 10 to 15 minutes, I am going to share. Okay. So kindly check the email or WhatsApp group. I will share with you. You can attempt. Try to answer all the questions. All are mandatory. Okay. Yeah, mark your attendance. Meanwhile, within 3 to 5 minutes, I am sharing with you the link for the test. Next is that we are going to conduct the offline FDP, which is mandatory, the part of this course. So that is going to start on 7th of November. So you are all are requested to kindly attend it at physically at NIT Uttarakhand, so that it would be a great, you can visit the land of God, that is Devbhoomi, Uttarakhand. And there is a lot of adventure around this apart from this FDP. We also have 1 or 2 industrial visit around the place and in Srinagar itself. So certainly you will take a look over there what kind of relevant visit we will arrange. The refreshment and hospitality, the refreshment and lunch will be provided by us. So kindly visit us. Thank you. So I will share shortly the link of the test. So check your email or WhatsApp group. Thank you very much for attending all the sessions patiently. If you have any question, you can turn off and unmute yourself and let me know. Any questions?
No, sir.
Okay, I'm sharing the link of the test. Okay. Thank you.
Thank you, sir.